Fantastic. Let's take a look at problem number 7. In problem number 7, it's asking us about the function f of x, and it's given us a quadratic of x squared minus 14x plus 9. It's asking us to say which of the equations listed has the correct vertex and vertex form of this quadratic right here. Well, in order to figure out the vertex or the vertex form of any quadratic, the easiest thing we can do is graph it. Now I go to my calculator and I graph this thing, and it comes out looking like that. That doesn't tell me too much. It definitely doesn't tell me where that vertex is. It's somewhere down here. I know that it's definitely going to have to be a positive value of x. Something like down here would be my vertex, and then continue like that. But we can't see it perfectly. So what we're going to do is we're going to use our table. Okay, so let's go to the table right here. Take a look at our y value. See how that y value keeps dropping down? Well, let's keep on scrolling until the y value doesn't drop down anymore. Went down again, negative 31 to negative 36, right? Keeps on going, keeps on dropping down. There it goes to negative 40. But what did you notice right there? At negative 40, that was as low as it got. Then it starts going up again. There's negative 39, negative 36. So right here at 7, negative 40, that's our turning point. Oh, and also remember that the axis of symmetry would be through x equals 7, right? And as you can tell, see how it's negative 39 on top of the negative 40 and negative 39 on bottom of the negative 40? And if you spread out, here's your negative 36, here's your other negative 36, negative 31 here, and negative 31 here. It spreads out from that 40, the negative 40. So if we go back here, we know that our vertex is at 7, negative 40. Now, if we're putting that into vertex form, we know that that's y equals a times x plus h quantity squared plus k. Remember, when we're inserting in the 7 for the h, we're going to have to change the sign of the one that goes with the x. So we'll have a times x minus 7 quantity squared. We put in the negative 40. That sign doesn't change. So minus 40 goes right there. And it looks like from the multiple choice answers, we don't even need to worry about that a, because it looks like that a value is going to be 1. And of course, 1 in algebra we don't always have to write. So we can also just erase that guy right there. Nice. So now we're ready to move on to problem number 8. Problem number 8 asks us to compare the graphs of f of x and g of x. In class, we always looked at g of x as our parent function, or the function that always got manipulated by other things in front or with the x or at the very end. So if we look at g of x, it's going to look like this. There's our parabola for g of x. Well, let's remember, the vertex right here is 0, 0. So let's think real quick. What happens when you subtract 5 and you add 4? That subtract 5 is going to make our vertex go to positive 5. And this 4, we keep the sign of the constant, is 4. So we know the vertex is going to be at 5, 4. So what happened with this vertex here? If it's going from 0, 0, I don't know, up to here to 5, 4, what happened to it? Well, it moved 5 to the right and 4 up. Okay, now let's talk about what that number 2 in the front does. Remember that a in the front, if it's negative, it opens down. If a is positive, it's going to be opening up. So it's positive, so it didn't change the direction of where this graph is going. If we remember the absolute value of a is greater than 1, then we know that the graph is going to get narrower. And if the absolute value of a, that front number, is less than 1, we know it's going to get wider. So let's look here. The value of a in the front is 2, which is bigger than 1, so it's going to get narrower. So this, the way g of x will be changed if it became f of x, well, its vertex would be moved to the right 5 and up 4. It would also be narrower. Okay, let's take a look at problem number 9. It says, which quadratic function has the largest maximum? All right, we can remember that maximums are the same thing as a vertex. So let's look at answer choice number 1. Answer choice number 1 says h of x is equal to negative x minus 4 times 5 plus x. Well, I'm going to go right to my calculator right here and type that in. Instead of h of x, of course, we'll use y1, negative x minus 4, and parentheses, times 5 plus x. And we hit the graph. Uh-oh. The vertex looks like it's a little bit off the screen. So let's use our table to figure out where that vertex is. I'm going to hit second graph to go to the table. All right. It looks like our y values are going down, 20 to 18 to 14 to 8 to 0 to negative 10. All right, it's going down. Still going down. All right, so it's continuing to go down. Let's see, does that match up with what we predict on the graph? Ah, yes. These values are going down. So it looks like our x value is going to have to be maybe very small or even negative if we get to the top value up there. So let's go back to the table. Okay. Let's see what's happening now. Here, the values seem to be going negative 70 to negative 52. It's going up. Negative 52 to negative 36. It's going up. Negative 22 to negative 36 to negative 22. It's up. Negative 22 to negative 10. It's going up. Negative 10 to 0. It's going up. 0 to 8. It's going up. 8 to 14 going up. 18 to 20 going up. And then somewhere in between negative 1 and 20, I'm sorry, negative 1 and 0, we've got our vertex. Looks like it maxes out at 20, maybe juts up a little higher than that, and then it gets down to 20 again. And we can see in this one, our axis of symmetry, don't tell anybody I'm writing on the calculator screen, is right here, right in between those two 20s. So the vertex of this one, if I was going to give it a guess, would be something like in between negative 1 and 0 and 20. So something like maybe negative 0.5 and 21, something like that. That's just a guess. But we know that the maximum value is going to be a little bigger than 20. All right, let's take a look at answer choice 2. Answer choice 2 says k of x is equal to negative 3x squared minus 6x plus 4. Well, let's see where that vertex is to see if it has a maximum, or see what its maximum is. Negative 3x squared minus 6x plus 4. We graph it. Okay, well that maximum, we can kind of just count it out all by itself, would be 1, 2, 3, 4, 5, 6, 7. Looks like it's 7 or 8. Let's just double check the table. Looked like it was around negative 1, 7. Looks like here's our symmetry, right? We got 7 in the middle, 4, 4, negative 5, negative 5, negative 20, negative 20. Here's our vertex at negative 1, 7. So it looks like the maximum is 7. All right, so we're looking for the largest maximum, so we know that 20 is bigger than 7, so 2's out. Let's take a look at answer choice 3. All right, answer choice 3, we've just got a table. Looks like our x values and our h of x values are like this. 0, 1, 2, 3, 4, 5, and our h of x values are negative 2, 1, 5, 1, negative 2, and negative 8. Looks like our values are going up until they get to 5, and then they start going back down again. And again, you can see the symmetry around 5. 1's on the other sides, negative 2's on either side. So it looks like the vertex for number 3 is 2, 5, and its maximum is 5. So that's definitely not it either, because it's got to be, it still hasn't beat that 20, which is what from our first answer choice. In number 4, you can just see what the vertex is. I'll just draw a really bad sketch of number 4. But right here, the vertex looks like, to me, it's 1, or maybe a little less than 1, maybe 0.75, comma, 11.5, something like that. That's what its maximum value is. This is our y value here. So its maximum is something like 11.5, which isn't even close to 20, so that's not the highest one either. Our answer of which quadratic function has the largest maximum has got to be choice number 1. Okay. Nice. All right, let's take a look at problem number 10. Number 10 tells us to solve the equation 4x squared minus 4x equals 3 and solve it algebraically, remembering that says set this expression equal to 0 and then factor to solve. So the first thing we're going to do is set this expression equal to 0. Well, that means we want this 3 to be a 0. So I'm going to go ahead and take that 3 and move it away from that side. If we move that 3 away from the side, we'll get 4x squared minus 4x minus 3. And since we moved the 3 over here, it changes its sign. That's why it becomes a minus 3. And after the 3 is moved over, there's nothing there, so it's equal to 0. All right, and now we need the factor in order to solve this. But the problem is there's a number in front of that x squared term. So this is one of the trickiest kinds that we know how to factor. So instead of just an x and an x in the front, we're going to put a 4x and a 4x in the front. We're going to notice that this second sign is negative, so our situation for our signs would be plus and minus. All right, now we need to create a factor tree to figure out what numbers are going to go in here after the plus sign and after the minus sign. So we're going to look at the first coefficient, the leading coefficient, 4, and we're going to multiply it by the last number, or the constant. In this case, I'm just going to use a positive 3, and that's going to be 12. So what we need to do is create our factors of 12. Factors of 12, you can use your calculator if you like, are 1 and 12, 2 and 6, and 3 and 4. 4 doesn't go into it, 5 doesn't go into 12, 6 goes into 12, but we've already written down 6 and 2. Now again, we're going to want to make sure that these numbers subtract to negative 4, the number in the middle. So we're going to look here and see which ones of these are 4 apart. Looks like it's 2 and 6. So we have to decide, is it 2 minus 6 or 6 minus 2? Definitely, since we want a negative 4, it's going to have to be 2 minus 6. So what we're going to do is insert the 2 right up into here, and the 6 right up into there. All right, now we end up with something like this. 4x plus 2 times 4x minus 6 leave our equals 0. And now we have to do something weird. We're going to look to see, is there a number that goes into 4x and 2? Well, we're going to notice that 2 goes into both of those numbers. And we're going to look at the 4x and the 6. Is there a number that goes into 4 and negative 6? Yep, 2 goes into both of those numbers as well. So we're just going to divide through by that common factor. 4x divided by 2 is going to give us 2x, plus 2 divided by 2 is 1. 4x divided by 2 gives us 2x, minus 6 divided by 2 is 3. We'll set that equal to 0. Now, if we want to solve this algebraically, what we're going to do is set up the two scenarios, which is that either 2x plus 1 equals 0, or the other scenario, 2x minus 3 equals 0. And then we can just solve these as we would normally. Take this 1, move it over to this side, and we'll get 2x equals negative 1. And then what we're going to need to do is divide both sides by 2, and we'll get x is equal to negative 1/2. On this side, we'll have 2x minus 3 equals 0, so we're going to take that negative 3, move that one over to the right-hand side. That'll give us 2x is equal to positive 3. Then we're going to divide both sides by the coefficient of the x, and we'll get x is equal to 3/2. There's our two solutions, found algebraically.